Last class we were talking about what is the addition of two vectors and what is the subtraction of two vectors. In today's class we will talk about how to find out the resultant of two vectors by using the simple formulas. So as you have seen the addition of two vectors, as you have seen, we have used our parallelogram law. We have used our parallelogram law of addition that says take two vectors and make the parallelogram with the help of that. Then the diagonal will give us the resultant of two vectors or summation of two vectors. Suppose if we have this one vector is my A, second vector is my B. If the angle between them is theta, and let me say they are forming a parallelogram. If they are forming a parallelogram, then the diagonal of parallelogram will give us R, that is sum or resultant of the both vectors A and B. And let me say the angle between A and R is my alpha. So here what we are saying, theta is the angle between vectors A and B, alpha is angle between vectors R and A. In that case we are not going to prove the formula but the resultant, because we know now here the R equal to what? A plus B, R equal to A plus B. So R is called a resultant or the sum of two vectors. The formula of the magnitude of the both vectors are, the magnitude of the vector R, then magnitude of the resultant, that is my R, because if you remember we have seen the magnitude of a vector is shown by the simple R like this or like this. So because we will use this, it is what? Easy for us. So in this case R is given as under root of A square plus V square plus 2AB cos theta. This is the formula that we have to find out the magnitude of the resultant of two vectors A and V, where theta is the angle between the vectors A and B. If we have to find out what is my alpha, then the tan alpha becomes B sin theta divided by A plus B cos theta. It is the angle alpha we can find out by using this formula that says the alpha tan alpha becomes B sin theta. Here it is my A, it is B, it is theta, it is alpha. So tan alpha becomes B sin theta divided by A plus B cos theta. By using this formula we can find out what is the angle between R and A. Now to do that we will first solve a simple problem. That problem says, suppose if we have two vectors, we have a simple question. Suppose if we have a question, now that says in this case suppose we have two vectors have same magnitude of 5 units each if one vector has makes an angle 30 degree with the x-axis and second makes an angle 60 degree with the x-axis, then find out the resultant. Find resultant, let me say is my R. Find magnitude of resultant. Find magnitude of their resultant. Now you can see from here, suppose if we take the x-axis my here and y-axis my here. Now there is a one vector is my, let me say call is my A, let me call as A. This is making an angle 30. We have second vector, let me say is my B, it is making an angle 60 with the x-axis. The magnitude of the first one, as you know, the magnitude is shown by simple A, what 5 units. The magnitude of B is also 5 unit. Then theta is how much? Theta is the angle between the two vectors, because angle here is 30, angle here is 60. So angle between them becomes 60 minus 30. So theta becomes 60 degree minus 30 degree equal to 30 degrees angle between A and B. Now we know the formula to find out the magnitude of resultant. Then R becomes root of A square plus B square plus 2AB cos theta. Applying this formula we will get A square is how much? 25, 5 square 25, again 5 square, 2, 5 into 5 into cos of 30 degree, cos of 30 degree. So in this case we know it becomes root of 25, 50, cos 30 is root 3 by 2. So this becomes 25 plus 25 plus 25 root 3, 25 root 3. In this case, if this becomes equal to, you can solve this further. So we can take the 25 outside, so it becomes 5, it becomes inside 2 plus root 3. You can solve it further, so it becomes the answer to find out what is the magnitude of the resultant of the vectors if both have the angle 60 degree and 30 degree with the x-axis. So this is the way we can find out. Now we will see what is the meaning of different kind of vectors. The one vector that is very important, it is called as null vector. It is called as null vector. The term itself indicate that something has to be null. Null means what? 0. So a vector that has magnitude 0 and some undefined direction, then it is called as null vector. The vector, if, so when we now see the second thing, when the two vectors are equal, condition for two equal vectors, condition for two equal vectors. That condition says if there are two vectors that have the same magnitude and the same direction, then they will be equal. So both must have same magnitude and same direction if two vectors are supposed to be the same vector. So if the one vector is my A, is this, second is my B like this, and third, let me say, is my C like this. Now as you can see from here, the length of A, B, C are same and all are indicating the same directions, thereby they all three are same. So they all three are same, A equal to B equal to C. So all three vectors A, B, C are same. Now we will see what happens if you multiply a scalar quantity, that means a number, with the vector. So if what we can say multiplication. Now we talk about the multiplication. What is the meaning of multiplication of a scalar, or you can say some number, with vector? In this case, if let me say we have a vector A, now if I am multiplying the 2 by quantity 2, then let me say, because my new vector is my B, suppose we have indicated vector A is my like this. Now if I multiply the 2, it means the new vector, that is my B, will be twice of the length of the A, but the direction will remain unchanged. So now you have twice of the length but indicating the same direction. So if you multiply a positive number to a vector, in that case only the magnitude will get changed but direction will remain unchanged. So we can say, if positive number is implied, if positive number is multiplied, then only magnitude will change, only magnitude will change. So if suppose I multiply 0.5 in the vector A, in that case this magnitude becomes half. So this becomes what? Half, and this becomes fairly half, and this becomes my 0.5 A, but direction remains unchanged. If I multiply a minus quantity, let me say I am multiplying a minus quantity minus 2 into A. In that case, as you have the negative of vector, first find out the 2A, 2A is my this, and then take minus of that, the minus will become what? This. The minus of 2A becomes this because anti-parallel and have the same magnitude. So this becomes the vector D. So now we can summarize, if you are multiplying a positive number with a vector, then only magnitude will get changed, but if you are multiplying a negative number, then both magnitude and direction will be anti-parallel, and magnitude will also get changed. So in today's class we have seen how to find out the magnitude of the resultant of two vectors. We have done one problem regarding that, and then what is the meaning of null vector, what is the meaning of two similar vectors, and what happens if you multiply a scalar quantity or simple a number with the vector. In the next class we will talk about the multiplication of a vector with the another vector. Thank you.